Okay, it's Mr. Benson here with the first part of the test answers, just starting at the level 8 questions. So, question 3, for the rule y equals negative 4x plus 2, what does y equal when x equals 3? So the idea here is that we are using substitution as the skill to actually answer this question. So what we need to do is to substitute for x in this equation, so replacing x with a value of 3. So if we write y equals negative 4, then we're substituting for 3, make that a bit of negative, plus 2. So then all we've got to do is evaluate this. So negative 4 times 3, so 4 times 3, remember, is 12, but it's a positive times a negative, so we get a negative answer, plus 2. Now negative 12 plus 2, we're going more positive, so it's going to be negative 10. Okay, so that's our first answer. So our answer for that one is going to be D. I have no idea why it's making those letters disappear. I'll draw that one again. Okay, moving on to the next question. Circle the position of the y-intercept on the following graph. All we've got to remember here is that the y-intercept is where the line crosses the y-axis. So that was a nice easy one, I hope. There is where that happens. Question 5. The y-intercept for the linear graph y equals negative 6x plus 2 is. Now this is just asking you to remember what the standard form of the equation is. So we write it as y equals mx plus c. Now when we're doing this, we've got two numbers that define our equation. So the first one here is m, so this is the gradient. C is the y-intercept. So when we're looking at the equation in the question, y equals negative 6x plus c, so negative 6 is the gradient, and therefore 2 must be the y-intercept. Now the important thing is, and this relates to the previous question about the y-intercept, the y-intercept is on the y-axis, so it happens when y equals 2. So our answer for this one is D. What threw a lot of people with this question, I think, is you just looked at it and saw the answer of 2, but you weren't looking at x equals 2. So x equals 2 would be the x-intercept.